So this evening's video talks about graphing a line with using the slope-intercept form of a linear equation. Isn't that a cool little thing I found on my Explain Everything app? And also direct variation, which is a type of line in slope-intercept form. Okay. So slope-intercept form is this. We have y equals mx plus b. Y and x are the values of y and x on the xy coordinate system. B is the y-intercept, so B would be like right here. Remember, x equals 0 there, and m is the slope of the line. And if this is our line, then this is our run, and this is our rise. So our slope is rise over run. So graphing a line using the slope-intercept form. The first thing we want to do is we want to rewrite the equation to solve for y. And when I say that, I mean you want to get y alone on one side of the equal sign. So let's say I have an equation like this. I have y minus 2x equals 4. Okay, so let's get y by itself. Well, I need to move this minus 2x from the left-hand side to the right-hand side. So I'll add 2x to both sides, plus 2x. Those cancel out and become 0, and I end up with y equals 2x plus 4. Good to go. Next thing I want to do is I want to identify the slope and the y-intercept. So my slope equals 2. And remember, slope is rise over run. So this is just a whole number, and I want to have it in fraction form. Well, 2 is the same as 2 over 1. So this tells me my rise is 2, and my run is 1. What's my y-intercept? Or the b equals, let's see here, the b equals 4. So b is my y-intercept. Okay, now what do? We want to, here's y, and here's x. I'll count off 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Make that a little longer, 6. Okay, so first thing we want to do is we want to plot the y-intercept. So my y-intercept is 4. So starting here, I go up 1, 2, 3, 4. There's my y-intercept. And, hold on. Now, my next thing I do is I locate a second point using the slope. What I'm going to do is I'm going to go for my y-intercept, and I'm going to rise 2 and run 1. So I go up 1, 2, run 1. There's my second point on my line. Last thing I do is I draw my line. So there we go. That's how we use the slope-intercept form to draw a line. Now, there's a special kind of linear equation called direct variation. Direct variation is special because it goes through the origin. Goes through origin. Where is the origin again, you may ask? The origin is right there. Okay, so y equals mx. This is the form of direct variation. The variable m is often replaced by the letter a, and it's called the constant of variation. So direct variation is a line in slope-intercept form where the y-intercept is 0, and the line goes through the point 0, 0, also known as the origin. So to determine if an equation is in direct variation, the first thing we want to do is put the equation to slope-intercept form. So what if I had the equation, let's see, 4x plus 2y equals 0. Well, right now this is not in slope-intercept form. What I need to do is get y by itself. First thing I'm going to do is I'm going to move this positive 4x from one side to the other. They cancel. I have 2y equals negative 4x. I'm almost done. But right now I got to get rid of this 2 because y is not by itself. So I have 2 times y, so to undo multiplication, I divide. So let's divide both sides by 2. They cancel out because anything divided by itself is 1. So I have y equals, well, negative 4 divided by 2 is negative 2x. So my constant of variation is is negative 2. All right, let's do some examples and see how this works. All right, let's see here. First thing I'm going to do, let's plot some lines using the slope-intercept form. So plot lines. Number 1, my equation is y equals 1/2 x plus 3. Okay. If I remember correctly from my first slide, the first thing I want to do is I want to identify my y-intercept. Well, b, my y-intercept is 3. My slope, m, is 1/2. And remember, the slope is the number in front of the x, or the number being multiplied by x. Okay, next step. Next thing I want to do is I want to plot my y-intercept. So my y-intercept is at 3. I go up to 3. And then I use my slope to find my next point. Well, my slope is a rise over the run. So I want to rise 1, run 2. There are 2 lines. Whoops, that is not a straight, or 2 dots, that's not a straight line. And there's my line connecting 2 points. Okay, let's try another one. What if I had negative x plus y equals negative 1. Well, is y by itself? No, it's not. So let's get it by itself. And I'm going to do that by adding x to both sides. So y equals x minus 1. Okay. My y-intercept is negative 1. I have to take the sign in front of the number. My slope, well, there's no number right in front of my x, and there's no number being multiplied by it. If there's no number, but the variable is there, we assume that the number is 1. So that means my slope is 1. That's just a whole number. I want to put it into a fraction. That'd be 1 over 1. Let's graph this bad boy. Okay. First thing I want to do is I want to graph my y-intercept. And this time my y-intercept is a negative, so that means I'm going to go down 1. I'm going to go down 1, hold on, right to there. And then my slope is I rise 1 and I run 1. So I go up 1, over 1. This is my second point. 2 points determine a line, and there is my line. All right, let's do one more of these types. What if I had 3y equals negative 2x plus 12? That's a 2. Plus 12. Well, I got to get y by itself, so that means I have to divide both sides by 3. And notice that, excuse me, I have to divide the entire right-hand side by the number 3. So, because I have 2 terms on top and 1 on the bottom, I can split this up, and I can say it's 2/3 x plus, what's 12 over 3? Well, 12 over 3 is the same as 4. Let's identify our y-intercept, which is 4. Our slope is negative 2/3. Okay? X, Y. That looks like an X to me. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, this one is a little different because my slope is negative. So what I'm going to do is I'm going to plot my y-intercept, which is 4. So I'm going to go up 4. 1, 2, 3, 4. 4. Now my slope is negative 2/3. That means either my rise is going to be negative or my run will be negative. And what I always do is always say my rise is negative 2, my run is 3. So I'm going to drop down to go down 1, 2 over 1, 2, 3. There's my second point. I draw the line. And I know the graph is going in the right direction because I have a negative slope. And a negative slope gives me a downhill line. So let's try some direct variation examples. So is it direct variation? That's our question. Problem 1 is 3x plus y equals 0. Well, I have to get y by itself, so let's do that. Subtract 3x, and I have y equals negative 3x. I need to check and see, is my y-intercept 0? Well, there's no number here. Excuse me. So my line only has a slope, and the y-intercept is not written here, so that means it is yes, this is dv. So check. All right, how would I graph this? The way I would graph it is it goes through the origin. So that, let's see here, my slope is negative 3, my y-intercept is 0. So that means there's 1 right there. I want to write that as a fraction, so I know. So that's my first point. To find my second, I rise negative 3, 1, 2, 3, and I run 1 right there, and that is my line. All right, how about the equation? How about the equation? 6x plus 3y equals 0. Well, let's get y by itself. Subtract 6x from both sides. I have 3y equals negative 6 over x, or negative 6 times x. Y is still not alone, so I have to get rid of this 3. So y equals negative 6 over 3 is negative 2x. So yes, this is direct variation, and my constant of variation is negative 2. Whoops. Negative 2. Negative 2. And I'm going to give you two more examples. So let me erase this stuff. And we will take a look at 2 more examples. What about, let's say 2y equals 4x minus 6. Well, y is not by itself, so I have to divide both sides by 2. So I have y equals 4 over 2 is 2x minus 6 over 2, which is 3. Looks like my y-intercept is not 0, so it is not direct variation. The last thing you're going to need to do, so let's just say a line goes through x equals 2, y equals 8, and it's direct variation. So you need to write the equation for direct variation. First thing you want to do is find the constant of variation. And the way you do that is you divide y by x. So I have 8 over 2, which equals 4. So that's my constant of variation. Now, if I want to put this into a direct variation equation, it becomes y equals 4x. And there's my direct variation equation. All right, I'll see you in class.